After completing this lesson, you will be able to link CAD and PDF files into Revit, manage linked CAD files, move linked files to the project base point, and pin linked files. The objective domains covered are 5.1a, understand the difference between imported and linked files, and 5.1b, manage linked files. When starting a structural project, design data from an architect or a surveyor is often used as a starting point of your design. There are two methods to bring CAD data into Revit. We can either link files or import files. When using linked files, the connection back to the original file is maintained, so if a newer version is issued, then we can simply reload that to update our Revit model. If we import files, then this is embedded into the Revit model and hence cannot be updated or reloaded. Go ahead and open up the model 001 link or import files. Once the model is open, notice in the project browser that we currently have the site plan open. In this particular project, the site plan has the project base point and the survey point already visible on screen. Click on the Insert ribbon, and here we can go ahead and link CAD. Once we're in the Link CAD Formats dialog box, you'll note in the Support Files folder we have grid setting out imperial.dwg. This is the file we're going to import into our Revit model. In the lower half of the dialog box, we're going to start by preserving the AutoCAD colours. We're going to make sure that we bring all of the AutoCAD layers through into our Revit model. And we want to automatically detect the units used. So the CAD file is set to feet and inches, and our Revit model is also set to feet and inches. The positioning is auto center to center. This is going to ensure that the centroid of our CAD model ends up in the centroid of our Revit model. It's inserted around the internal origin point of Revit. And here we're going to place this at level 1. For a survey, I would suggest that we uncheck the correct lines that are slightly off axis. And also, in this example, we don't need Orient to View activated. So let's go ahead and open the file. So you'll now notice that the CAD file is inserted into our Revit project. We're now going to go ahead and move it from its local datum, which is the intersection of grid A1, to the project base point. First, we select the CAD file. Up on the context ribbon, you'll note we have the Move tool. We're going to snap to the intersection of grid A1 and position this on the project base point. To ensure that the CAD file doesn't inadvertently move away from this selected position, we'll select our linked AutoCAD model, and on the context ribbon, we will pin the file. Next, we go ahead and import a PDF file. In the project browser, note that we have a drafting view. Let's activate the drafting view by double-clicking on PileCap Standard Detail. On the Insert ribbon, click PDF. In our Support File folder, go ahead and select 001.pdf. In the Import PDF dialog box, let's ensure that the resolution is set to 300 dpi and go ahead and click OK. We'll then place our PDF on the drafting view. Note that we can actually enable Snap on the PDF. If you require snaps when working with PDFs, you can select the PDF, and on the Modify Raster Images context ribbon, you'll note here we can enable snaps. Let's switch back to the site plan. So here we have our original linked AutoCAD file. Now, of course, the architect or surveyor may resend through a more up-to-date version of this file, or indeed the file name may change. If we are required to reload this, On the Insert ribbon, we can select Manage Links. In the Manage Links dialog box, you'll notice we have a number of tabs at the top to control the various different files that we can link in. The default one is Revit. In our example, we've used an AutoCAD file, so we can go ahead and click CAD Formats. So here you can see that we have our grid set in our Imperial file. Currently it's loaded in. We have our file size and the saved path for this file. If I need to reload it, I can click the Reload button. Or if the architect or surveyor has sent through a new file with a different file name, then I can go ahead and reload from, and I can then simply specify a new CAD file. After completing this lesson, you will be able to understand copy monitor and coordination, copy grids and levels from an architecture model, create a coordination report, and select objects with element IDs. The objective domains covered are 5.1c, understand the concept of copy monitor from a linked file. When working with an architect in a Revit model, you can use this model as the basis of your structural design. This enables you to stay coordinated amongst teams and avoid expensive reworks. Copy will create a copy of the selected elements, but allow you to map this element to another family type. Monitor will ensure that the elements remain synchronized. Go ahead and open up the file 002 Copy and Monitor. Once the file's open, you'll note that it opens in the site plan. Our first task is to review the linked files in this particular model. Go ahead and click the Manage ribbon, and on the Manage ribbon, select Manage Links. In the Manage Links dialog, you'll note that we have a Revit model already linked in, and if you select the CAD Formats tab, you'll also note that we have an AutoCAD file, again linked in. Go ahead and click OK. We're going to begin the process by copying the levels from the architect's model. To do this, let's go ahead in the project browser and open up the south elevation. Note on the right hand side we can now see the architect's levels. To start the copy monitor process, let's select the Collaborate ribbon, and on the Collaborate ribbon we'll go ahead and select Copy Monitor. Here we're going to go ahead and select the link. Note if we had multiple Revit models inside this project, the tooltip would display the correct Revit model. So in this case, we're going to go ahead and pick our architect's model. We now have the Copy Monitor Context ribbon open, and here are displayed all the tools required to take us through the Copy Monitor process. Let's begin by taking a look at the options. In the Copy Monitor options, note on the Levels tab, we have the ability here to see the architect's original types of levels and my types of levels on the right hand side. If I wanted to change the map in here, I could go ahead and select a different type. If we now select the Grid tab, here I don't want to copy any of the grids at all. So I'm going to use the Shift key to allow me to multiply select all of the types. And in the New Types column, let's go ahead and select Don't Copy this type. We'll select the Columns tab, and here you'll note that the default is Don't Copy this type. In fact, there's no columns in this project, and we don't need to copy any of these at all. Let's select the Walls tab. The only one I'm interested in is the Concept Wall 10 inch. So I'm going to go ahead with the Shift key again and select all of the remaining walls. And once again, set the new type to Don't Copy this type. And in fact, the mapping up here is exactly what I want. I want my concept wall 10 inch to map to my exterior 10 inch concrete wall. However, if we look at the additional copy parameters in the lower half of the window, you'll note that Copy Windows, Doors and Openings is checked. In this case, I do not want to copy those, so I'm going to uncheck that from the dialog box. And lastly, if we select the Floors tab, you'll note that all of the floors are going to be copied out to a generic 12 inch. Once again, I don't want any of these copied, so we'll go ahead and use your Shift key to select all of those elements. And here I can just say, do not copy this type. So there are our options configured. Go ahead and click OK. So we're now ready to go ahead and copy these levels. Click the copy button. On the options bar, make sure we check the multiple option here. This allows us to select multiple items on the screen. We'll then use a window selection. And just to ensure that I'm copying only levels, you'll note that we have filter selection again on the options bar. Let's go ahead and select that. And here I've just got levels selected. Once I'm happy with the selection, I can select the Finish button. And you'll note that Revit copies those levels through into my project, and also we have the monitor symbol over here. Next, we copy the core walls. In the project browser, switch to the 3D view. The first thing you'll notice with the 3D view is it doesn't much look like the architect's intention. The reason for this is our structural template is dictating the visibility of these architectural elements. To get this looking more like the architect's intention, we'll utilize visibility graphic overrides. Click on the View ribbon and then select Visibility Graphics. In the dialog box, select the Revit Links tab. Note here that the display settings are set by host view. We'll change this to by linked view. If the architect's model has multiple 3D views configured, we could select the relevant one from the list. Here we only have one view. Click OK and OK again. And you'll note here the Revit model now looks just like the architect's model. So let's now copy the core walls. Note on the ribbon, we already have the Copy Monitor Context ribbon active. Once again, we'll select the Copy tool. Check the multiple option on the options bar. And window select the walls. Again, we could check that we've only got walls selected by using the filter selection. And then I can click Finish. Note now the walls are copied and they're also monitored. I'm now finished with Copy Monitor, so I can go ahead and select the Finish button. Now, to help us understand exactly what we're looking at here, we can now switch off the visibility of our architect's linked file. Click on the View ribbon, then select the Visibility Graphics tool. Select Revit Links tab and uncheck the visibility. So note now that I have my core walls displayed. Finally, I'd like to show you what happens if we reload the architect's model when we've received a revision. Select the Manage ribbon and then Manage Links. In the Manage Links dialog box, in the Revit tab, you'll note that we have our original architect's model. Here, we're going to go ahead and reload from. Let's go ahead here and select 002 Architect's Revit Model v2.0. Once the model's loaded, you'll note that Revit comes up with a warning saying that the instance of this linked model needs a coordination review. So we'll say OK to the Manage Links dialog. Before we can select the link, we'll now need to reinstate the visibility of our architect's model. So we can go to the View ribbon, select Visibility Graphics, select the Revit Links tab, and make sure it's visible. Now we'll select the Collaborate ribbon and select Coordination Review. Click Select Link and pick the linked file. Note now in the Coordination Review dialog, we can see here that we have a level moved by 1 foot. And also here we have a wall center line that's moved and is different. If we zoom into the model behind here, we can see the change. So this is the original wall. Here is the new position in V2. What I'd like to do here now is put some actions in. So I'm going to reject the change, but we'll accept the change on our wall. I also have the ability to add comments. So I'm going to select the Add Comments option. And here I can add a comment to send back to the architect. So I've put a comment in here, roof levels need to remain unchanged. I can then select OK to the Edit Comments dialog box. And here I could create a report. The report is simply saved as a HTML file. I could email this to the architect. What you'll also notice here is we have an element ID for each of the elements that have changed. The architect can simply select those elements by the element ID to identify the elements that I'm referring to. After completing this lesson, you will be able to create grids, create levels, modify grid and level family types, create structural plans, and also work with scope boxes. The objective domains covered are 5.3a, modify level and grid types, and 4.1b, view properties. A structural grid defines locations for elements such as columns and walls. If the grid line is changed, the elements that are referenced to them would also adapt. Levels define building stories and create and control vertical datums. Many elements can be created to start and end on building levels. If the level changes, then referenced elements will also adapt. A scope box can control the visibility and extents of datum elements such as grids, levels, and reference planes. In the example below, two scope boxes are used to control the position and vertical extents of a grid. Go ahead and open up the file 003, create additional grids and levels. Note in the project browser that the active plan is level 1. Our first task is to create structural grids from the architect's linked file. To do this, we'll select the structure ribbon and then go ahead and pick the grid button. On the context ribbon, we're going to utilize the pick lines method. I'm going to begin by selecting the grids in sequential order. So this is grid 1, so when I select this, you'll see that Revit then creates a new grid referenced from the architectural grid. I can then proceed through the rest of the sequential grids and let Revit create a new grid based on the architect's grid lines. Here, you'll notice that Revit references this as grid 10. Whilst we're in the grid command, we can simply put a new reference in this case 9A. So we now need to create the multi-segment grids used on grid A, B, and C. To do this, we'll select multi-segment. Again here, we can utilize the pick lines, and we can then pick the two lines representing grid A. Once I've selected those, I can select the Finish Edit mode. And again, it's important then to rename the grid. I'll then right mouse and repeat the grid command, select multi-segment, and then select pick lines. Finish the edit mode, and note that this is now taken on the next grid, grid B. Let's repeat that whole process for grid C. We can then create the last three grids by clicking grid, and again by going directly to pick lines and picking off the last three elements. Our grids are now created. To enable us to see these better, we can go to Visibility Graphics and switch off the linked model. On the View ribbon, select Visibility Graphics. On the Revit Links tab, uncheck the Architect's model. Here are our structural grids. Once these grids are created, it's recommended that the grids are pinned in case you accidentally reposition these. So we can window select all of the grids and select Pin. Note that the arrangement of grids looks quite untidy. The reason for this is some grid heads are displaying on end 1 and others are displaying on end 2. We're going to edit the family type of the grid and consolidate this. So select one of the grids, and you can note here that all the grids are using this family type 1/4 inch bubble. Let's go ahead and click Edit Type. In the Type Properties dialog box, you'll note here that we have our symbol used for our grid, but also here you can see that we have two options, the Plan View Symbols End 1 and Plan View Symbols End 2. I'm going to ensure that both of these options are checked, and then click OK. So now note that the arrangement of the grids looks much nicer. We also need to suppress the two grid bubbles on grid F, so I'll go ahead and select both of these, and here's the arrangement that we were looking for. We can do a very similar thing with the levels. So in our project browser, let's switch to the south elevation. On the right hand side here, you can see that we have our levels currently being shown. All of the symbols are on the left hand side. What I'd like to do is edit these so the symbols only appear on the right hand side. So we can select one of our levels. Again, in the Properties palette, we can click Edit Type. And again, note here that we have symbol at end 1 or symbol at end 2. We'll ensure that symbol at end 1 is checked and symbol at end 2 is unchecked. And here are our levels updated. Next, you generate structural plans from the levels we've just created. On the View ribbon, under the Plan Views drop-down, select Structural Plan. Select all the levels in the list and click OK. Revit has now generated all of the plans. We now create a scope box to control the grids on the right-hand side of the structure. On the View ribbon, select Scope Box. We're going to create a scope box, just roughly about this size here. This is an arbitrary dimension. What's important now though is I rotate the scope box to match the rotation of my building structure. You'll notice here that we have a rotate tool built into the scope box, but this won't allow us to accurately define the rotation. So instead, we're going to use the rotate command. We'll place the center of rotation on our grid. And here I can pick a straight horizontal line and then snap the scope box to the same rotation as our grid. We can then use the shape handles on the scope box to fine-tune the overall size. In the Properties palette, you'll note that we can give the scope box a name. So I'm going to call this one Wing B. And I can then select the grids that I'd like to control with this scope box. Once I have the grid selected, note here I can select the particular scope box that we'd like to use, in this case Wing B. So you'll now notice that grids have updated to that scope box. You may want to change the vertical extents of our scope box. We can select the scope box, and in the Properties palette, under View Visible, we can select Edit. Note here that in the 3D view, I could override the visibility and set this as visible. And I'll do the same in the south elevation. If we now take a look at the south elevation, You'll now note that my scope box is visible, and once again, I can use the shape handles to control the extents of my scope box. If I wanted to here, again, I could select my levels, and I could assign those to the same scope box. Note in 3D, we also see the scope box.